All right, welcome to part 2 of the one-dimensional kinematics tutorial. In this part, I want to look at a couple of things that are going to come up in your homework a lot, and really honestly kind of throughout the year. First thing is, among your problem-solving tips, a really important fact to know is this right here, that when you throw something up in the air, or when it rolls up an incline and then comes back down, the velocity at the top is 0. All right, now that won't actually be quite true. We'll learn when you do something like throw a football, because it's not like the football goes, stop, fall straight down, because that's what would happen if it just stopped at the top, right? So it does keep going at the top, but vertically speaking, it does stop going up. Okay, so the vertical velocity is 0 at the top. All right, so it's going to be true for any number of problems in one-dimensional kinematics anyway, where if you throw something up, you're going to be able to usually do something with the fact that at the top of its motion, its velocity is, for an instant, 0. Okay, so if it goes up, there it is, at the very top, you can say velocity equals 0. All right. Next thing is parabolas are symmetrical. Okay, now why would that be useful? Well, if you think back to the soccer ball up the driveway problem that we were doing a minute ago, it was kicked, it said at 4 meters per second up the driveway, and then it rolls back down the driveway. There's actually another way that you could have done that problem to still get the same answer that we ended up getting. And that would be this. You could use the number 1 equation, right? If you figured out the amount of time that it took for the soccer ball to go up the driveway by knowing that it stops at the top, it didn't go all the way up, but stops at the top of its motion. And then if you say it's going to take the same amount of time to go up as it does to go down, well, then you can just double your answer and get the same thing. All right, so let me look at that. Here's a little sidebar real quick. It said that it was kicked with an initial velocity of 4. All right, well, actually, negative 4, if you recall, is what we figured out because it was kicked in the opposite direction. All right, at the very top of its motion, the velocity is going to be 0. And then the acceleration is 1.25, we figured out. So then if I do some division here, 4 divided by 1.25 should work out, assuming that I didn't do bad math, to 3.2 seconds. All right, so that would be the time up. The time down ought to be the same because the acceleration is the same in both directions, and therefore the total time is 6.4 seconds, which was the answer we got at the end of the last video. All right, so you can very often use that fact to your advantage. The only case where it's going to break down is if you have some significant air resistance in the problem. That is not going to come up in this course ever at all for any reason, because dealing with air resistance is difficult, requires differential equations and other nasty things like that. As long as you get to ignore air resistance, though, which is valid for any reasonably dense object, if you throw a baseball up in the air, it's going to take the same amount of time to reach the top as it is for it to come back down to your hand. All right, now, where this breaks down in what you will have to work with in this course would be the following. If we have a wall and we're standing at the top and we throw a ball, all right, clearly time up and time down are not the same for something like that. But as long as you can make the assumption that it's returning to the same position from whence it started, we'll be able to do something with that. All right, meaning you can say the time up and down are the same. All right, the other place where you can use this actually though is this. For even in this scenario, right? If the velocity with which this particular object was thrown was, say, 6 meters per second. All right, so its velocity was 6 meters per second up. When it gets back to that same height on the way down, its speed will be 6 meters per second, just in the opposite direction. Okay, so the velocity will, at that moment, be -6. Okay, so that's another really useful feature of parabolas, regarding the fact that they are symmetrical, is that for the path of something going up and down, even if it's moving in a straight line, right? You can say that when it's at the same height, it's going to have the same velocity, or excuse me, have the same speed going up and going down, the only difference being one's going up and one's going down, and therefore the signs are opposite. Okay? All right. Third thing, not all solutions are valid. Sometimes that means that you screwed up. If you get no valid answers and you know that there's a solution to this problem, that would mean that you messed up somewhere, and usually it's the signs. I mean, like 9 out of 10 times. You have something negative that should be positive, or positive that should be negative. Okay, so for example, if you have a question, again, like, well, let's take, throwing things onto, flat surface like that, okay? All right? And you want to know, when does it get back to the ground? Okay, something like that. Let's actually ask a different question. Sometimes there are two answers. So if I throw something up in the air and I want to know, when is it going to be 5 meters above the ground? And I threw it hard enough that it gets up to, of course, 10 meters above the ground. That would be a heck of a throw, but let's just say I did that. All right, well, it's going to be at 5 meters above the ground at 2 different times. How can I solve for 2 different times, Mr. Errico? That sounds like crazy talk. It's not crazy talk. Look at this equation. It's a quadratic. So if you plug that one into, if you plug all your numbers in and everything and you're asked to solve for time, it's a quadratic, and polysimul is your friend on your calculator. Okay, or the quadratic equation. Either way, you will get 2 valid solutions from this, assuming you plugged in all the numbers correctly, because there are 2 moments when it is at that position. That will be indicated in your answers by you getting 2 positive numbers. Okay, now, Mr. Errico, what if I get a positive answer and a negative answer? Like, when would that happen and what does it mean? That would happen for something like this. Okay, so if you have, you throw something off of a wall, right? And you want to know, when would it land? Because the calculator doesn't know any better, it will say that it happens twice. It'll say it happens at -1 seconds and +4 seconds, or something like that. Well, clearly the negative answer means nothing. Only the positive answer has significance. All right. Another scenario would be where you have no real roots. So that might go something like this. You have something, let's take it the other way around. You're throwing something up onto a high place. All right, well, obviously, if you don't throw it hard enough to get up there, then the answer is never. It will never be up that high. So, if I want to know, when will the ball be 20 meters above where it was thrown, the answer can be never. If you get no real roots, then that means it never makes it that high. All right, Mr. Errico, I have a question, though. I'm doing a question like this, and I'm getting no real roots. What am I doing wrong? Because clearly, it has to hit the ground sometime. It will hit the ground sometime. Okay, you can get no real roots in a case like that because of a sign error. So, fundamental question here. Let's say this cliff is 10 meters tall. All right, so that means that the displacement as you throw it is, okay, well, first thing on this is we don't actually care how high it goes. That's not important at all, right? All that actually matters is, where did it start, where did it end? And if the difference between those positions is 10, then you don't need to worry about how high it went. It doesn't matter. Okay? Ultimately, its displacement is going to be 10 meters below where it started. Okay, so now the word below there is the key to this, though. Very often, people will plug in delta x equals 10 meters. But it should be, if you're thinking, I have no idea. Okay, which way is positive for the vertical axis? Usually, up is positive. So you'd only have a displacement, a vertical displacement of positive 10 meters if you threw something up in the air and it landed 10 meters above where it started on a high ledge or something. So this actually would be a displacement of negative 10. All right, so it's usually signs is going to be the thing that messes people up. All right, so many times for these questions, people will get no real roots, or they'll just get a wrong answer and wonder what happened, and they have the wrong sign for the displacement. Another thing that will frequently happen is, if it's a not quite so tall wall, and we throw it upwards, you may get a really, really short time interval, or you may get two positive roots. And there's only one answer. It only lands once. What happened? Well, if you said that the displacement was, say, positive 5 instead of negative 5 like it should be, you could accidentally be solving for the two times when it will be 5 meters above where it started. All right, so if that happens to you, then again, you messed up. Okay, and so therefore, check back over your signs. Think about which way is up and which way is down. And in this case, that would be exactly what went wrong, because you should have had a negative displacement. All right, the other common place where people mess up is going to be on initial velocity, the sign for that, right? So if something is thrown upwards and gravity acts downwards, the initial velocity is positive and the acceleration is negative. If, on the other hand, you're talking about throwing something downwards, well, then that would be a negative initial velocity. And if you put a positive, then you will get some weird, wrong answers. Okay, I think that covers everything I wanted to hit in this video. So I would recommend at this point that you look at example 13. So work it out to the best of your ability, and then check the answer key in the posted study guide, in the notes packet key in the Google Drive. And if that makes total sense, then go on and start on the homework. There's one fact I guess I got to mention at this point that I did not before, and that is that when you're talking about throwing things, the acceleration due to gravity is always negative 9.8. All right, and so I guess I should actually be careful here. Let me rewrite this. Gravity, G, has a value of 9.8 meters per second squared. Therefore, for any problem where things are just falling or being thrown upwards or whatever may happen to be, which are called freefall problems, which just means the thing is not touching the ground, right? It's not touching a surface, okay? Then the acceleration is negative g, because it's 9.8 meters per second squared downwards, okay? So for any kinds of questions like that in your homework where it's a thrown object or a dropped object, that's going to be the value that you will use for your acceleration. All right, so check out example 13, fill it out in your notes packet, and then you should be set for the homework. Thanks, guys.